Voice is audible now?
Yes, sir.
Okay. So good afternoon, everyone. Welcome you all for NTA lecture. So in the previous lecture, we have completed the M-derived filters. So what do you mean by M-derived filters? Introduction part we have completed. And after that, we have discussed about the M-derived low-pass filter. Okay. So how to design the M-derived low-pass filter, we have discussed theoretically. And after that, we have solved one design problem also. Okay. So after this point, we are going to start now the second M-derived filter, and that is what? M-derived high-pass filter. So that part we are going to cover today, so that we can complete the filter part today only. Okay. So we can start now the M-derived high-pass filter. The screen is visible for you, everyone.
Yes, sir.
Yes, sir.
So M-derived high-pass filter, we are going to start today. M-derived high-pass filter. So if you understood the M-derived low-pass filter, then you can easily understand the M-derived high-pass filter. Only the position of inductor and capacitors are changed here. Okay, and we can take the reference of constant K-type high-pass filter. Constant K-type high-pass filter चा reference घेऊन तुम्ही M-derived high-pass filter design करू शकता, because there is modification in constant K-type high-pass filter, so that it will form what? M-derived M-derived high-pass filter. But modification काय बाबा, that we can discuss. So here first of all I will draw the diagram of T section and pi section of M-derived high-pass filter, and then we can discuss one by one. So first of all, consider M-derived high-pass filter. Consider M-derived high-pass filter with T section, and pi section, T section and pi section, as shown in figure A and B respectively. Okay, consider M-derived high-pass filter with T section and pi section. So in the high-pass filter, if you are considering the constant K-type, in the high-pass filter, in the series arm, capacitor is there, no? Series arm मध्ये? Yes or no?
Yes, sir.
So capacitor only there. Two capacitors are connected in series here in the series arm. Value we will see later. Now in the shunt arm there is a inductor in case of constant K, but here both are present. Okay, inductor as well as capacitor. So inductor along with capacitor I am drawing in series. So this is what T section. Now next pi section I will draw. In the pi section, in the shunt arm as usual inductor, but in the series arm there is a, along with capacitor, their inductor is connected. So here in the series, in the shunt arm there is a series resonance circuit, and here in case of pi section, in the series arm there is a parallel resonance circuit. So that is what it will get formed. So what will be the modification as compared to the constant K type? इथं फक्त काय झालं, कॅपॅसिटर ऍड झाला, and here inductor is added. Okay, in parallel with this capacitor here in series. That is only modification. Now the name, this is what the figure A, that is the T section of M-derived filter. M derived high pass filter, M derived HPF. So this is figure B, that is the pi section of M derived high pass filter. Okay, now the value. So here, what will be the original value in case of constant K type high pass filter? That is the 2C. Okay, so only here, whenever the capacitor is there, you have to divide the M. 2C by M, 2C by M. 2C is always already there in the case of constant K type. So just divide by M. Now inductor value, L divided by M, you can do it for the shunt arm. Now here 4M divided by 1 minus M square into C. So these value you can remember. There is no option without remembering. Value हे तुम्हाला लक्षातच ठेवावं लागेल. दुसरं कुठला ऑप्शनच नाहीये. For M derived, you have to keep the values by observing, by recording, what we can say, mug up or by heart. तुम्हाला ते पाठच करावं लागेल. So these are the values of inductor and capacitor in the series resonance circuit in the T section. Now here 2L already is there. 2L by M. 2L by M. Now for capacitor, only C was there. So C by M. For inductor, it is 4M divided by 1 minus M square into C. Okay. So these are the, what we can say, T section and pi section of M derived filters. So observe the diagram, everyone. Observe the values, how the elements are connected in the T section and pi section of M derived high pass filter. You can observe it. Now we can consider the T section now for being case, out of these two you can consider any case. Either you consider T or pi. Now consider from T section of M derived high pass filter. The shunt arm consists of, the shunt arm means this one, parallel arm, consists of series resonance circuit.
काय माहिती आरेच होते.
Who is talking?
शाळा बा लुंगीनगडे
Ashwini Tawan. Okay, from T section of M derived high pass filter, the shunt arm consisting of series resonance circuit, which is shown here. Okay, so it has the minimum impedance, therefore the output is 0 at resonance frequency, and due to which infinite attenuation we can get. So we have already made modification in the constant K type, so that in the series resonance circuit it will get formed. Mag series resonance circuit kadi resonance frequency, at resonance frequency, what is the impedance? What is the impedance in the series resonance circuit at resonance? Anyone? So at resonance, what is the impedance? Anyone? At resonance, the impedance is 0, no, because no resistors. At resonance, the impedance for series resonance circuit is 0. Why it is 0? Because there is no resistor. Actually, it is Z is equal to R for series resonance circuit, but no resistor is no here. So R value is 0. So that's why at resonance the impedance of the series resonance circuit is 0. That's why due to this we can get infinite or 100% attenuation. We can consider infinite, or we can consider 100% attenuation. 100% attenuation in which band? Stop band or pass band?
Stop band.
Yes, very good. So we can get 100% attenuation in the stop band. ओके, म्हणजे कट ऑफ फ्रिक्वेन्सीच्या पुढची जे काही फ्रिक्वेन्सी असतील ते सगळे टोटली अटेन्युएटेड व्हायला पाहिजेत. ओके, सो दॅट इज आवर एम. सो दॅट विल हॅपन्स ड्यू टू फॉर्मिंग अ रेझोनन्स सर्किट हियर. फक्त इंडक्टर होता, त्यावेळेस कॅपॅसिटर आपण काय केलं, कनेक्ट केलं, मॉडिफिकेशन केलं, सो दॅट इट विल गेट शॉर्ट सिरीज रेझोनन्स सर्किट. मग सिरीज रेझोनन्स सर्किटचं प्रॉपर्टी काय? ऍट रेझोनन्स इट विल गिव्ह द झिरो इम्पेडन्स. ओके, अँड ड्यू टू विच वी कॅन गेट द 100% attenuation in the stop band. So one more thing, at resonance we are going to discuss what will be the condition for resonance.
XL equal to X.
Yes, very good. So the condition of resonance we have to use for getting the expression of m. m चे expression derive करण्यासाठी आपल्याला ते condition use करावं लागेल. But condition at resonance is XL is equal to XC. So this is why we are making the frequency equal. Why we are making equal? So here at resonance, when XL becomes equal to XC, the voltage across both becomes equal in magnitude, but 180 degree out of phase with each other, as well as the impedance becomes minimum, that is R value, but R value is absent here. That's why the R value is 0. And due to which what will happen? The attenuation we can get maximum in case of stop band. So this derivation we are getting for deriving the expression of the m value. Okay, where m will decides what will be the scaling factor. So m means modified value. So XL is equal to XC. So consider f alpha as a resonant frequency in terms of omega, that is omega alpha. So at resonant frequency, f alpha, so XL is equal to XC. So XL means what? We can consider omega alpha into L. So what is the value of L in case of series resonance circuit? That is L by M, no? So you can take this one, L by M. So omega alpha into L by M is equal to XC means what? 1 upon omega C. So omega is omega alpha. So C value is what? This one, that is 4m into C divided by 1 minus m square. So this small m will get cancelled. Omega alpha into omega alpha I take in the left hand side, that becomes omega alpha square. L you can take in the right hand side, that will becomes this 1 minus m square goes to the numerator. 1 minus m square divided by 4LC, that is remaining. Omega alpha square is equal to 1 minus m square divided by 4LC. So take the square root. Take square root on both sides. Take square root on both sides. Both sides. We get. Take square root on both sides. We get. Okay. So what we are getting? Omega alpha is equal to under root 1 minus m square divided by 4 चा under root घेतल्यावर काय आलं 2.
2.
So LC चा आहे under root L into C. So that we are getting here. Now again here omega alpha means what? 2 pi f alpha. is equal to under root 1 minus m square divided by 4 into under root LC. Sorry, either 2 will na?
2 into.
Yes, 2 into. That is 2 into under root LC. Now this 2 pi you can take in the right hand side. You will get the f alpha. So f alpha is equal to under root 1 minus m square divided by 4 pi into under root LC. So this is my first equation. This is my first equation. Okay. Now next, what is the cutoff frequency formula for high pass filter? Already you learned the high pass filter for constant K type. So for high pass filter, constant K type high pass filter, the cutoff frequency FC is given by, we know that formula of LNC, but we don't know the formula of FC. So from LNC you can get the FC equation. So for high pass filter, the equation of cutoff frequency FC is given by, FC is equal to 1 upon 4 pi into under root LC. So this is my second equation. So put second equation in the first. Put second in first. So 1 upon 4 pi into under root LC is replaced by what? FC. So f alpha becomes, f alpha is equal to under root 1 minus m square into FC. Okay, from that you can get the value of f alpha and FC. In terms of that, you can get the expression of m. So 1 and 2 equation you can remember. So up to this point, you can read it each and every point. So after that, we can continue. I will give the 30 seconds. You can read each and every steps. If you not understood any point, you can ask here only, because we are going to continue after this. कोणाला काही क्वेश्चन्स असतील तर विचारून घ्या. Okay, so I will remove this point, theoretical point. Okay, now next equation 1 and 2 we have. So put equation 2 in equation 1. We get, put equation 2 in equation 1. So what we are getting here, FC is equal to, f alpha is equal to
FC into root 1 minus m square.
Yes, root 1 minus m square. So root, you can take f alpha divided by FC here. F alpha divided by FC, you can take in one side, is equal to root 1 minus m square. So take square on both sides. Take square on both sides. So what you can get, f alpha divided by FC bracket square is equal to 1 minus m square. So m square you can take in another side, and this you can take in another side. So m square is equal to 1 minus f alpha divided by FC bracket square. Okay, now we want the value of expression of m. So take square root on both sides. Square root on both sides. So m is equal to under root 1 minus F alpha divided by FC bracket square. Okay, so this value, this expression will gives the how to find the value of M if you know the cutoff frequency and resonant frequency. So this is my equation number 3. Okay, now from this expression, I want to ask one question here. So here F alpha is greater or FC is greater?
F alpha.
What? Greater? Which value is greater?
FC.
FC.
Yes, FC value is greater. Why? Because if FC value is greater, then and then M value you can get within that 0 to 1. Because M value I told, it should be less than 1 and it should be greater than 0. So to achieve that, F alpha is less than FC. Denominator जास्त पाहिजे. तरच तुमचं 1 पेक्षा कमी आन्सर येईल. जर डिनॉमिनेटर जास्त झाला तर मायनस मध्ये जाईल ना, मग 0च्या इकडं या रेंज मध्ये जाईल तो. सो यू कॅन कीप इन माइंड एम व्हॅल्यू जर तुमचं 0 पेक्षा कमी म्हणजे मायनस मध्ये आणि 1 किंवा 1 पेक्षा जास्त येत असेल, 1 किंवा 1 पेक्षा जास्त जर येत असेल तर तुमचे फॉर्म्युला चुकलाय किंवा कॅल्क्युलेशन चुकलंय. Are you getting my point? So this is cross check. This cross check you have to do. So this is what the expression of M. So here you can put the condition. So what is the condition from this equation? The resonant frequency F alpha is less than cutoff frequency. Cutoff frequency FC. Okay, the resonant frequency F alpha is less than cutoff frequency FC of high pass filter. So this is what the theoretical part I want to discuss with you, so that we can cover the M derived high pass filter. After this, there will be the design. So once we can discuss the design formulas, then we can start to solve the numerical example. So any questions? After the equation 2, you can read it, the left hand part, and observe the diagram. If any query, any questions will be there, you can ask. So you are putting equation 2 in what? In equation number 1, so that we can get the relation between F alpha, FC and M, and we got M expression. So after that, we can guess that, we can conclude that resonant frequency F alpha is less than cutoff frequency FC. But for low pass filter, exactly opposite. Okay, then in that case, resonant frequency F alpha is greater than cutoff frequency. आणि इथे एक्सप्रेशन मध्ये पण चेंज होणार, तिथं लो पासला FC वरती असणार आहे, F alpha खाली असणार. Any questions? Okay, so we can move towards the design. So design of M derived low pass filter we have completed. Similar way, we are going to solve the design of M derived high pass filter. Design of M derived high pass filter. So first of all, what are the equations we need for designing the M derived high pass filter, that we will see. So first equation, that is the M value, M expression. M is equal to here under root 1 minus F alpha or FC, which is in the denominator and numerator.
F alpha.
जे लहान असणार आहे ते न्यूमरेटर मध्ये, F alpha divided by FC bracket square. Many students are forgetting here to make a square. Next, second one, high pass filter चे equation for high pass filter. What is the equation of L?
K up 4 pi.
K upon
4 pi. 4 pi.
K upon 4 pi FC, that remains same. Similarly for capacitor or high pass filter. Capacitor just K take in the denominator. So 1 upon 4 pi K into FC, where FC is what? FC is what? Cutoff frequency of high pass filter. And F alpha is what? Resonant frequency of, or resonant frequency, you can just note down resonant frequency. So these two values they will give, and from that you have to calculate M, and after that L and C you can calculate, and after that draw the diagram and mention the names, and after that you can put the proper values by doing the calculation part. If M value is there given, either they will give F alpha or FC. तिन्ही पैकी एक दोन पॅरामीटर तुम्हाला ते देतात. M is the first, F alpha is the second, FC is the third. या तिन्ही पैकी दोन पॅरामीटर द्यायलाच पाहिजे, त्याशिवाय तिसरं कॅल्क्युलेट करता येत नसतं. ओके, सो वी कॅन स्टार्ट द फर्स्ट न्यूमेरिकल एक्झाम्पल. ओके, सो first question we can start. So design of M derived high pass filter. Design of M derived high pass filter. So question is design an M derived high pass filter. M derived high pass filter with a cutoff frequency of of 10 kilohertz, comma, design impedance of 500 ohm, and M value is given 0.4. So this is what the question. So how to start now? First of all, write down the given things and which filter you are going to design. That name you can write down. So M derived HPF we are going to design. So after that M value is already given, means there is no use of using what M expression use करायचं का नाही? M expression is needed or not to use. M value is given directly 0.4. M expression use लागतंय का नाही? I'm asking
No.
you people only.
No.
Yes, because it is not needed. Only we require what? FC. कारण L आणि C चं कॅल्क्युलेशन करताना आपल्याला फक्त FC लागतो, F alpha लागत नाही. Okay, so M is equal to 0.4. Then FC is given as 10 kilohertz. And K value is given as 500 ohm. Okay, now first point, for high pass filter, what is the formula to calculate the L value? L is equal to K upon 4 pi FC. So K is replaced by 500 divided by 4 pi into 10 kilo. So calculate and tell me what is the value of L you are getting. K when goes to the numerator becomes milli. Other things you can calculate. L is equal to, everyone has to calculate and mention in the chat box.
3.978 millihenry.
येस 3.97 किंवा 3.98 जरी घेतलं तरी चालेल. 3.978 millihenry. 3.98 is also okay. 3.98. Okay, now 3.978 or nearly equal to 3.98 millihenry. Now next, capacitor value C is equal to 1 upon 4 pi k into Fc. So 1 upon 4 pi into k value is 500 into 10k. So C value calculate and tell.
$15.91 nanofarad.
Yes, very good. 15.91 nanofarad. If you are taking the microfarad, then it is 0.0159 microfarad. Both are acceptable. So C value and L value we have calculated. Now next, you have to draw the diagram of T section and pi section. Now the M derived high pass filter is given by. So you can draw the T section and pi section. So T section I will draw. Capacitor is there. So in the shunt arm, inductor and capacitor. So this is what T section. So pi section I will draw. In pi section, inductor and capacitor are connected in parallel. That will get parallel resonance circuit in the series arm. And here inductor. Now this is what T section. Figure A. T section. M derived HPF. Now here B, pi section, M derived HPF. Now you can mention the values here. We know that 2C by M, here L by M, and here in case of low pass filter it is 1 minus M square divided by 4M असं होतं. आता ते उलट असणार आहे. So for high pass filter 4M divided by 1 minus M square into C. Similarly for pi section 4M divided by 1 minus M square into L. So for capacitor C by M, here it is 2L by M, and here also 2L by M. So you have to calculate all these values and then mention in the diagram. So what are the calculations here? (2C by M) you have to calculate. Second thing, L by M you have to calculate. मग L by M calculate केले की 2 ने multiply करा. Okay, 2 into L by M. Next 2C by M, पहिला C by M calculate करा. C by M calculate केले की नंतर 2 ने multiply करता येतो तुम्हाला. That is the fourth point. 2C by M. Fifth point, 4M divided by 1 minus M square you can calculate. Into L you can calculate. And after that, sixth point, 4M divided by 1 minus M square into C. You can calculate. So all these value calculate and tell me. so that I will put in the diagram. चलो C by M किती आलाय? C by M
39.775
nanofarad, बरोबर आहे? So C by M where it is required in the pi section. So it is what? 39.7 nanofarad. Next 2C by M दोन्ही मल्टिप्लाय करायचं त्याला, मग किती येणार? 79.5 something, 79.5 nanofarad, 79.5 nanofarad. So 2C by M and C by M over. So I will write C by M is 39.7 nanofarad and 2C by M is 79.5 something nanofarad. Now next L by M. L by M 9.945, बरोबर आहे?
Yes.
9.945 millihenry. So L by M is here 9.945 millihenry. Now next 2 L by M we requires. So multiply 2. So that will get nearly 18 point something or 19.89 millihenry. बरोबर आहे? So that is required here in the pi section. 19.89 millihenry. 19.89 millihenry. Now next 4m divided by 1 minus m square into L. So this calculation requires more time somewhat. Calculate and tell.
Seven point 57.
For 7.57. Okay.
Yes.
So 4m into L divided by 1 minus m square is 7.577 to 57 millihenry. 7.57 millihenry. Very good. So similarly 4m into C divided by 1 minus m square, how much it is?
120.552.
120. No. Once again check. It is 30.2 something I am getting. 30.2 nanofarad. Everyone cross check. Only one student is giving answer.
30.30.
Yes. So 30.30 nanofarad. That is my answer. 30.30 nanofarad. So this is what the design of M derived high pass filter. अजून वेगळ्या पद्धतीने जर विचारायचं झालं तर कसं विचारणार? Design an M derived high pass filter with cutoff frequency of 10 kilohertz, and they will also mention the resonant frequency f alpha. They will mention the design impedance. So based on the cutoff frequency and resonant frequency, you can calculate M value. That is the only extra step. So M expression is already known. So M formula you can use to calculate, and then you can start for calculating L and C, and after that drawing the diagram, calculation part, and mentioning all those values in the design of M derived high pass filter. फक्त M value जर directly दिला असेल तर एक step कमी होतं. If M value is not given, instead of that, if they have mentioned the value of cutoff frequency as well as resonant frequency value, then you have to calculate the M value, because everywhere we require M here. Okay, 2C by M, L by M. So everywhere M value is required. So this is about what the design of M derived high pass filter. So we have completed all the filter parts. So just we have to discuss the advantages of M derived filters. There are the 3 advantages are there. Those are advantages with respect to M derived filter over the constant K type. Constant K type मध्ये जे ड्रॉबॅक्स मिळत होते, जे डिसएडवांटेजेस मिळत होते, that those we can overcome by using modification in the constant K type, so that we can get the advantages. So we can discuss those, and after that, before that, summary we can discuss with respect to design. Summary for M derived filters. So in the form of tabular, we can discuss it. How already we discussed for constant K type. So summary for M derived filter. So serial number I will take if you want. Then constant K type and M derived. Okay, so first of all, constant K type low pass filter if you are considering, and if you are comparing with constant M derived low pass filter, what are the formulas are there, that those you can write down. So for constant K type, so L value is what? L value is what? K upon pi FC. Yes. So here it remains same. L is equal to K by pi FC. बरोबर है? Now next, C is equal to 1 upon pi into K into FC. So here also same, 1 upon pi into K into FC. Now next, one more formula required for M derived filter, and that is what? M value. So M is equal to under root 1 minus F alpha is greater or FC?
FC.
Yes, so it is FC divided by F alpha bracket square. So that formula we requires. So next, serial number 2. Serial number 2 for high pass filter. Here also for high pass filter M derived. So L is equal to what? Only 4 you have to multiply in the denominator. K upon 4 pi FC. C is equal to what? 1 upon 4 pi K into FC. So for high pass filter, again the formulas are same. L is equal to K upon 4 pi FC. C is equal to 1 upon 4 pi K into FC. जे फॉर्म्युला सेम आहे, फक्त M चा फॉर्म्युला डिफरंट आहे. So M is equal to what? Under root 1 minus F alpha divided by FC bracket square. So compare these two M expression. Here FC divided by F alpha is there for low pass filter. For high pass filter, F alpha divided by FC is there. That is only different. So this is what the summary in the tabular form we can remember. Okay, so this is what the summary for M derived filter here. So you can remember this table so that you can remember all the formulas. So as I have compared with constant K type low pass filter and high pass filter, you can easily remember the formulas for M derived low pass filter and high pass filter. So any questions from this point? Any questions?
No, sir.
Okay. So we can discuss
No,
three
sir.
advantages. We can discuss three advantages of M derived filter and then we can stop. So these advantages already asked in the university question paper. So advantages of M derived filters. M derived filters over the constant K type filters. Constant K type filters. So there are the three advantages I already told. So three advantages we can discuss one by one. M derived filters have a sharper cutoff frequency, characteristics at cutoff frequency FC. So actually a sharper, this word is actually a sharper attenuation characteristics, we can call it sharper attenuation characteristics. M derived filters have sharper attenuation characteristics at cutoff frequency FC. So what do you mean by this? So we are expecting that the filter should behave like ideal filter. Okay, practical filter behave like ideal filter. That is our expectation. But we are not getting a sharper attenuation characteristics at cutoff frequency. We are getting somewhat curve. So that to avoid that, to minimize that, we are going to modify in the constant K type. So after modification, we can call it as what? M derived filter. So that is the advantage. So suppose I am taking the low pass filter here. Any consider low pass or high pass. Suppose you are talking about the attenuation 0 in case of low frequency. So low frequency you can consider. Yes. So nearby sharper we are getting. So this is what FC. So attenuation characteristics alpha here, and this is what frequency. So this is what stop band. This is what pass band. I have considered the attenuation characteristics of low pass filter. Attenuation characteristics of low pass filter. So here the sharper cutoff frequency we are getting. That is advantage. Now second advantage is what? Characteristics impedance Z0. Characteristics impedance Z0 remains same for all frequency. Characteristics impedance Z0 of M derived filter. M derived filter is uniform. Uniform means constant. Uniform means constant. Okay, within pass band, especially within pass band, when M is equal to, if we are keeping M is equal to 0.6, then we are getting uniform characteristics impedance at all frequencies in the pass band. At all frequency in the pass band. So within pass band, when M is equal to at all frequency. Next, third one, M derived filters. M derived filters are used to construct composite filters. So this is the application point of view advantage I am telling. Composite filters which have any desired attenuation characteristics. म्हणजे जेवढं पाहिजे तुम्ही तेवढं डिझाईन करू शकता. एनी डिझायर्ड म्हणायचं आपलं, डिझाईन नाही, एनी डिझायर्ड means whatever the value we can make it changes, have any desired attenuation characteristics. So composite filter means we can design by using passive filters, we can design easily so that we can get any desired attenuation characteristics by using what? M-derived filters. So these are the advantages of the M-derived filters over the constant K type. So read it everyone, each and every point. So if any questions will be there, you can ask. So we have completed now the filter part from this unit. Only attenuator part is remaining. So maximum 3 lectures we require to complete the attenuator part. If no questions, we can stop. Okay, thank you.